Today we'll be reading a ACT prep on friction. Friction is a force that resists the motion of objects. A group of students are conducting experiments on friction. Experiment number 1. Diagram 1 depicts a procedure that is used to make the friction force. A horizontal force is applied to a block on a table to accelerate it from rest. One observes that the force needed to initiate the motion, or accelerate it from rest, is greater than the force needed to sustain the motion at a constant speed. Masses can be added to the block, thus increasing the load represented by the letter L. The force required to initiate the motion is equal to the static friction force, also known as F sub static. The force required to sustain the motion at a constant speed is equal to the kinetic friction force, also known as F subkinetic. Table 1 represents typical data from such an experiment. Experiment 2. A student decides to investigate the effect of the surface on the amount of friction. She layers the bottom of the block with coarse sandpaper and then repeats the procedures described in Experiment 1. Her data is shown in Table 2. And the data can be seen in tables 1 and 2, where you have trials, the load, F substatic, and that's a force in newtons, and F kinetic, and that's a force in also newtons in both tables. Experiment number 3. Another student makes an effort to determine if the area of contact between the block and the table affects the amount of friction. The scientist finds a rectangular block with 3 unequal length sides. The areas of the face of the blocks are side A 65 centimeters squared, side B 42 centimeters squared, and side C 78 centimeters squared. The student pulls the block without the sandpaper along each of the sides at a constant speed. The data are shown in Table 3. And Table 3 takes a look at the load, side A and the F kinetic, side B and the F kinetic, and side C and the F kinetic, and that can all be seen in Table 3. The questions. Question 1. In what way do the students control the load in these experiments? A. They cause more friction to be present. This in turn affects the load. B. They pull with a different force. The amount of load varies with changing force. C. They place the block on various sides. Varying the contact area affects the load. Or D. They add or remove masses to or from the block, and the load varies with the mass. Number 2. What information is learned in Experiment 2 that had not previously been learned in Experiment 1? A. The students learned the effect that the surface might have upon the force of friction. B. The students learned the relative strengths of the static and kinetic friction force. C. The students learned the effect of load on the amount of friction experienced by the block. Or D. The students learned the effect that the contact area between surfaces has upon the friction. Number 3. Which is an independent variable in Experiment 3? A. The amount of load on the block. B. The force of friction acting on the block. C. The amount of force needed to pull the block. Or D. The contact area between the block and the surface. Number 4. Which statement is consistent with the data collected in Experiment 1 and Experiment 2? A. A greater contact area between block and surface results in greater friction force. B. Changing the contact area has little to no effect upon the amount of friction force. C. Varying the mass of the block does not have any effect upon the amount of friction. Or D. For the same load, a sandpaper surface causes more friction than a plain wood surface. Number 5. Which of the following relationships were not studied in Experiment 1, 2, and 3? A. Effective contact area on friction. B. Effective pulling speed on friction force. C. A comparison of static and kinetic friction. Or D. Effective surface material on friction force. Number 6. A group of students are dragging a block with a constant speed across the same surface used in Experiment 3. Its contact area is twice that of side B, and the load is 4.58 newtons. Use the results in Experiment 3 to predict the force that must be applied to the block. A. 1.32 newtons. B. 2.62 newtons. C. 5.26 newtons. Or D. 9.16 newtons. Number 7. Which of the following set of characteristics would result in the greatest force of kinetic friction? A. Small load, sandpaper on the bottom of block, largest contact area. B. Large load, no sandpaper on bottom of block, largest contact area. C. Small load, no sandpaper on bottom of block, smallest contact area. Or D. Large load, sandpaper on bottom of block, smallest contact area. Number 8. In which case was the amount of kinetic friction the greatest? A. Use a load of 2.91 newtons and no sandpaper on the bottom of the wood block. B. Use a load of 3.42 newtons and sandpaper on the bottom of the block. C. Use a load of 4.41 newtons and no sandpaper on the bottom of the wood block. D. Use a load of 3.92 newtons and sandpaper on the bottom of the wood block. Number 9. An effort is being made to initiate the motion of a wood block having a load of 5.91 newtons. What would be a reasonable estimate of the amount of static friction? A. Approximately 3.18 newtons. B. Approximately 3.44 newtons. C. Approximately 3.5 newtons. Or D. Approximately 3.83 newtons. Number 10. In experiment 1, a force is applied to the block until it is set into motion. Once set in motion, the force is applied to pull the block at a constant speed. Which graph represents how the force varies over time during a trial? And you can see 4 different graphs represented below. Good luck. We'll talk to you guys later.